Okay, y'all. So this is going to be 3.3. Sorry, I'm trying to get it to be without that on the bottom, but I guess it's not going to go away. Okay, so this is 3.3, which is truth tables for conditional and biconditional statements. Okay. So for our conditional statement, what we use is an arrow that points in one direction to the right. What we say, or what you will see in like the sentence form, will be if, and you'll also see the word then. Okay. And then we're going to go ahead and draw a little PQ table to show how to do this operation. So we have our P, we have our Q, and then we would have, it says if P, then Q. That's how it's read. We can go ahead and write that right here too. Read if P, then Q. That's a funny looking R. Okay. So the simple truth table for two statements is TTFF on our P. Because this is all of the different cases. Our Q, you start with T, and it alternates truth values. So you have case 1 where they're both true, case 2 where one is true and one is false. Our case 3 is when the first one is false and the second one is true, and then case 4 is where they are both false. Okay. So I have this little side note right here. For our conditional, it is true in every case except when you start with T. The conditional could also be considered kind of like an implication. So it's like when you start with T and you're implying false. This is going to be the only time that you get a false like outcome or truth value. And so seeing that, if you look at your different cases, this is case 2. This is, in this case right here, I'm starting with T and I'm looking at F. So if I'm doing if P then Q and I'm right here, it just told me that that is the only time that I get my false outcome. Everywhere else you get true. Okay, now we could actually construct a truth table that's slightly different than this truth table right here. Okay, so we're just going to go ahead and say example. Construct a truth table for not P, then not Q. So if you notice, it's going to be slightly different than this one right here because they've both been negated. We will need to do our little truth table with P column, Q column, and then I will go ahead and throw the statement that they gave us right next to it. And we have true, true, false, false, true, false, true, false. Using the same pattern or type of like process that we did to do our truth values in a truth table, we would start with our negations. I will first negate P right here, and then I will negate Q. And then after I do that, the third thing will be to use this first column that I worked on and the second column that I worked on to get this conditional answer column, which I've numbered 3. So if I negate P, the not P means to take the opposite truth values. Right? This is saying not P. Here it'll be saying not Q. So not P is the opposite truth values. If you look at your column for your P, it's T, T, F, F. The opposite truth values would be F, F, T, T. And then you would do the second chunk of work, basically right here, underneath your not Q. That means negate Q. So it means look at your Q column and negate all of these values. It goes true, false, true, false. So the negation of that column would be false, true, false, true. Now after you've done that, essentially you're done with these right here. I'm looking at what I've numbered 1 and what I've numbered 2 to answer 3. And the operation that I'm doing is this if-then operation. And if you look up here, I know for a fact that the only time I'm going to get false is when I start with T and I go to F. If I see anything else, it's a true. Okay? So I see started F, go to F, that's a true. F to T is true. T to F is false. T to T is true. And then let me grab a highlighter. Was that too dark? Probably. I'm gonna grab a yellow one. TTFT is the truth value, or like the answer for this statement. Not P, then not Q. Okay? Okay, awesome. Let's move on. Okay. So now we're going to do a very similar setup for the biconditional statement. So same type of thing. What it is, what the symbol is, what words we use, and then the little P and Q truth table, and then an example. Okay. So, biconditional statement. Biconditional statement. I almost spelled it wrong. Biconditional statement. Okay, so the symbol that we use with a biconditional statement is an arrow that points in 2 directions. We would see the words if and only if, which as shorthand is IFF. Here what you do is you look for doubles. So double T's or F's. They need to be the same. That's how you're going to end up getting a true statement. Here we could say that double T's or F's give true value. Okay, so we have our P and our Q, and we're going to do a P if and only if Q. And then we just do the values. I've done them a lot. TTFF for your P, TFTF for your Q. And then right here, okay? Now my little note is true, only, oh man, only, O-N-L-Y. It's true only when P and Q have the same truth value. So true only when P and Q have the same truth value. So T if and only if T results in T, as well as false if and only if false. That also results in T. A lot of people, this would be like a common mistake, right? T if and only if T is T. The mistake would be to think that F if and only if F would give you F, but it doesn't. That's actually going to give you a true value. So if you look at our little table, that's case 1 and case 4, right? That's the first case where they're both true, and the fourth case where they're both false. Everything else, the other 2 cases, your outcome or what you get ends up being false, okay? Because it's only case 1 where they're both doubles and matching, 2 T's, and then case 4 where they're both doubles or matching with 2 F's. Okay, now let's do our example. So we're going to construct a truth table for so not P if and only if open, not Q, then R. Okay. So for this particular example, y'all, we do have 3 statements. We have a P, a Q, and an R. So we won't just have our 4 cases like we have right up here. We're going to have our 8 cases. On the back of the review, I put all the different 8 cases. So if an example uses a P, a Q, and an R, you have that first initial setup. And on the test, you'll also have it. Okay? Just kind of does take a second to set it up on our paper right here. We have our P, our Q, our R, and then what we're going to have next to it is going to be the whole statement that they gave me, which was not P if and only if, not Q, then R. And that second set right here, this is what was in our parentheses after the if and only if symbol. For an 8-case truth table, the P is going to have 4 T's and 4 F's. The Q will go in sets of 2. And then the R alternates, TF, 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 TF. Okay, so that is our whole truth table for an 8 case, or whenever we have 3 simple statements. So what I would do first, because we're in math class, is to negate inside of the parentheses. So right here, right, you always start with inside of your parentheses, and because this Q is being negated, I need to do that first. So underneath that, I'm going to put the number 1. Still working within my parentheses, I would notice that I have an R right here, and nothing is negating it, so I would just be copying down my R column. And then the third thing I would do is apply this conditional, and that would actually be like the answer column for this parenthesis. Then after I did that, I would negate this P, which is out front. And then lastly, I would look at the answer for my parenthesis and the 4th thing that I did to get the final answer, which is going to be this if and only if operation. Lots of words. Okay, so the first thing I would do is negate this Q. So it's technically like not Q. Not Q means negate Q, which means take the opposite truth value of Q. If you notice, it's TTFF, TTFF. So the negation of that would be FFTT, FFTT. The second area I need to work at is just my R. There's no negation in front of it, so it's kind of just telling you to copy R. And R alternates beginning with a true value. Third thing, now that I have the not Q and I have the R, I can take the implication between them both. I can take the conditional between them both. I didn't really write it, but y'all, that's just R. Okay, the conditional, if I start with T and I go to F, that's the only time I get an F. You could just find those times. Put your F and then fill in T's everywhere else. Or you can do row by row by row by row. It's whatever makes the most sense to you. Okay, I'm going to find them and then I'm just going to fill in the rest. Order does matter. You have to start at T and go to F. Okay, it's not any combination of opposite values. It's start at T, look at F. So T is on your left, F is on your right. So here's a T, and it actually goes to T. So I don't really care about that one right now. The next case, T to F. If T, then F, that's a false. If I find it again, I do at the very last case, that's a false. What can I do with all other 6 cases, y'all? Yes, class. Just fill them in with T's, right? So 1, 2, 3, 4, 5, 6. I counted just because I know there's 8, and I want to make sure that I get all 8 up there. I had 2 F's, so I would need 8 T's. Okay, y'all, this middle column, because it's underneath this conditional symbol, and that is the overall operation happening in these parentheses, this is the answer column for these parentheses, okay? Which is why I have like a little asterisk next to the number 3. The fourth thing I'm going to do is negate my P. P is 4 T's and 4 F's. So the negation would begin with 4 F's and end with 4 T's. And I don't have lined paper, so it's definitely not lined up. Obviously, there's no lines. Okay, now we're going to do an if and only if. Okay, now I hope it makes sense. Yeah, this 4 and this 3, 4 negated that P. So this essentially is the answer column, right, for this left-handed side of the if and only if symbol. And then this 3 is the answer column for the parentheses. I told you if you want to bring extra markers or pens or whatever, remember on the test you can only use pencil. But as far as covering things up, those are the only 2 columns that I'm looking at to answer this if and only if. Okay? And, oh, y'all, I didn't write it. This was us doing not P, right? So this if and only if, this is the actual example to what we just did here. And you notice how if I have 2 T's, I get a T, and if I have 2 F's, I get a T. So I just write TT, comma, FF equal T. I didn't actually do the symbol each time. It's just to kind of save space. I smushed it and really did shorthand there. Okay. I'll go ahead and do this so that it can hopefully help. I'm looking for doubles. All right. These are not the same. No. No. Yes. These are the same. These are the same. And then the second to last, so the 7th case, I have 2 T's. And then the 8th case, I have a T and an F. So everything else that was not doubles or representative of this little hint here that I gave myself results in an F truth value. And that right there would be the answer column for that whole entire statement. So this is what like you would be highlighting or circling just to indicate that it's like, this is my last column of work. This is what the answer is. Grade this. Okay, this is where I look when I grade. If I notice that here's an F, then what I do from there is I'll kind of branch my way backwards to C. And if you can get as close to it as possible and then mess up, you get, partial credit. If none of it is correct, then obviously you wouldn't get as much partial credit. Does that make sense, y'all, for the biconditional? Okay, if then, order matters, T to F. That's it. That's the only F. Okay, biconditional, we need both to be the same. Okay. So let's talk about the different type of statements that we can have. That was an answer column, right? This is one statement, had a whole bunch of different things happening to it. We did all of the work, and then we have an answer column, okay? So looking at and just considering those answer columns, we can kind of define these different types of statements. The first one that we're going to define is called a self-contradiction. Oh man, I knew it. I was looking at how bad I wrote my C and I started spelling contradiction wrong. Contradiction. Self-contradiction. Okay, what is a self-contradiction? A self-contradiction is a compound statement, which is like what we just worked on. That is always false. So in other words, y'all, all truth values in answer column are false. So on that previous example, the one that I highlighted, it would literally be F, 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 F. Every single one is an F. That actual compound statement would be a self-contradicting statement, just called a self-contradiction. Hopefully y'all have noticed some pattern to the way I've been doing my notes. We just defined a self-contradiction. So now I'm going to give you an example of a self-contradiction, okay? So this says construct a truth value for, so open P if and only if Q, close and open P if and only if not Q. Okay, I like the fact that all I see is a P and a Q, right? Because we don't have to do those 8 cases. I'm not saying we don't have to do another one today, because I'm actually positive. Yeah, there's a homework example here. I'm actually positive we do have to do it today. I just remembered, for y'all's, for this class, your 3.3 homework, I do need to extend it. I might need a reminder. There was a confusion in the dates because we are technically like half a class behind the other one. Okay, so I will extend that 3.3 homework to this Sunday because it's very similar to this. Well, it's not very similar. It's exactly what we're doing today, and y'all are just now seeing it. Okay? Okay, so construct a truth table for, we have P if and only if Q, and P if and only if not Q. Only see a P and a Q. Only need a P and a Q. Truth table. True, true, false, false. True, false, true, false. Okay, just gonna go ahead and write each and every single thing that I see here because it is just one compound statement. So open P if and only if Q, and open P if and only if not Q. Parentheses. Okay, so it's not only just parentheses, you work on those first. The negations are very important, right? And I notice that this second parenthesis has a negation. I'm going to put these notes on Canvas, so I'm going to follow what I did on here so y'all's notes aren't any different. But now looking at it, I would probably do this one first and then I'd probably finish the second parenthesis. What I did, because it's just both of them being parentheses, I actually started here. I actually just started right here. I don't need to do anything with the P or the Q, y'all, because I can just apply this operation. I don't need to write P and then write Q and then do the operation because nothing's being negated. Okay, so if I do this operation, this is where you're looking for doubles. This is a T, T, F, F, give you a T. That is case 1 and case 4. Everything else is false. And then I look over here and I'm like, oh, okay, so this one does have a negation. I will need to negate that first. Then after that, because I had to list that negation, I will need to copy my P. And then the last thing I will do within the parentheses is the operation of the biconditional. And then lastly, y'all, just to go and finish right there, I will take the conjunction of this and the last thing I worked on here, which is the 4. So that answer column and this answer column. Okay, so for this second step, I negate Q, false, true, false, true. For the third step, it has P not being negated, so you just copy your P. Fourth step, I'm actually looking at 2 and 3, and it'll be the answer to this parenthesis. If and only if I want doubles. That's a double, that's a double. Neither of those two are. And then lastly, I'm looking at 1 and 4. Right? This is the answer column to this parenthesis, and this is the answer column to this parenthesis. I have a conjunction. Y'all, this was not Q. This is doubles. And then this is and. I need both of them to be true to result in a true. It's the only time I get a true. So I notice here, well, y'all, tell me what my answer column is going to be. Yeah, because I'm doing an example of the self-contradiction, right? So if I look here, is this and this true? No. Is this and this true? No. Is this and this true? No. Is this, you kind of see what I mean? The answer column that I get in the end, after working individually on all of these columns, is all falses. And so, you know, you could say, therefore, a statement is a contradiction. You could actually write that whole entire statement there if you wanted to. But I know this is my answer column too because it's the last column that I worked on. It's the fifth one. And those are all false. That makes sense, y'all? You do the work. The whole entire chapter 3 is all of these truth tables. And if you're asked, you know, is this a self-contradiction or whatever this next one is I'm fixing to explain to you, that's what you're looking for, is you look at the truth table answer column. Okay. So, here, self-contradiction, all false. Okay? Another thing that we could see for these compound statements is called a tautology. So if a self-contradiction has a answer column of all falses, a tautology is going to have an answer column of all truths, okay? So, and the actual definition is pretty much the exact same with like 2 words change. So a tautology is a compound statement that is always true. All truth values in answer column are true. Okay, now, my option here was to do another example, but when I defined a contradiction of having all falses and we did the example, what did we get? All falses. If I do an example here of a tautology, my answer column is going to be what? All truths. Okay, so we're going to kind of skip that one because obviously, like, that's going to be the gist there, okay? I do have like an asterisk here or like a little note. A compound statement is neither if answer column is combination of truth values. So if a problem says determine if this is a self-contradiction, and you start working on that truth value table, right, the truth table, and it wants to know if it's a contradiction, you're looking for all F's. As you're answering it, you see one single T. That would make that statement neither a tautology nor a self-contradiction. Okay, so tautology, all T's. Self-contradiction, all F's. Combination of, it would be considered it's neither of them. Okay? Now, y'all, just a heads up, this right here, what we're fixing to do, I really enjoy and I like it more. I view it as a simpler way of solving truth tables. If you don't have to do a whole entire truth table and all the different values, but instead they give you a case, right? Here it says, give me the answer. And we have to look at every single case, and then we know that answer to that truth table, right? If they actually tell me, figure out the answer and do it when P is true, Q is false, and R is false, the only place we would look is right here at the true. They're giving us one of the cases. We don't care about the other 7. So instead of doing this whole entire table, we literally would kind of work on it the way you would a little bitty like expression, and you end up getting a T or an F for your answer. Okay, the hope is that it doesn't confuse anybody because it's supposed to be like a simpler way of doing it. Okay, and I really like this way. Okay, so determine truth value of statement given values of the simple statements. So how to determine truth value of statement given truth values of the simple statements P, Q, and R. And then I have a little note here. This is something that we did in 3.2, so it's similar to that work, I believe. Okay, so let's do this example. It says given P is false, Q is true, and R is false. Find the value of okay, y'all, what is this? P false, Q true, R false. So this is false, true, false. It's saying don't set up this whole table, right? If you did set it up and you want to do all the work, more power to you. I would love that, but you don't have to. Okay, false, true, false. Where's false, true, false? Here is false, true, false. So that's case 6, right? The answer to this, if this was the statement that they gave me, would be true. But instead of setting it all up, you can do it just working on each individual little chunk, okay? What they gave us is open, P and Q, close, if and only if open Q, or not R. Underneath this compound statement, I'm going to place the truth values that I was given. Okay, keep all the other symbols. Okay, until you actually apply that operation, keep the symbols. I need to keep your parentheses as well. Okay, so open, P is what? False. So I do a capital F. I see the symbol for conjunction. I'm told that Q is true, close, if and only if open. Q is true, or, and then it says not R. So that's actually the negation of R. So if I look, the value they gave me for R is false. Not R would be true. And then I work on the left parenthesis, keep this if and only if biconditional symbol, and then work on the right parenthesis. And then the last step will be to apply that conditional. I'm so sorry, the biconditional. So here, okay, you can keep your, I didn't actually keep my parentheses anymore because I'm just going to have one truth value after this. This is the and, right? With my and, what do I need? I need T and T to equal T. I have F and T. Is this and this true? No. So the result of this gave me an F. If and only if. This is my or. What's the hint with or? The hint with or is this or this true. The only time I got false was when they were both false. What is this? Here they're both true. Is this or this true? Yeah. And then for my doubles, that's what I look for, right? With the biconditional, right? Are these doubles? Are these the same? F, if and only if T. These are not doubles. These are not the same. And on the conditional, why do I keep saying that? The biconditional, this is F, if and only if T. What is that? That's case 3. I result in a F. And that's because with that symbol, okay, with the biconditional symbol, I'm looking for TT or I'm looking for FF to get my T. And what did I have here? I had an F, if and only if T. These aren't doubles, so I get an F. So it's just saying, instead of doing that whole entire truth table, to find this one row where P is false, Q is true, and R is false, and doing all of that work, you could just set it up like this. You can only do that if you're given the individual truth values for these little statements, okay? You can't do that without those little truth values. Everybody good? There is a homework example that we're going to do right now, and it is a PQR, but I did it with the other class, so I'm going to do it in here as well. Okay, I'm going to wonder. Let me write this down first, and then I'll explain it. Okay, so it's like a homework example. What it does is it asks you to do row by row. And you should be able to do it row by row, in all honesty. You should be able to look at it on your piece of paper. It would technically be having you create this whole big truth table, okay? But that can get frustrating. So instead, I would just look at the problem they want you to solve for the compound statement, do the whole entire truth table, and then as it asks you row by row, you're looking at your answers and you're just entering them in that way. Okay, so it asks you to do it row by row. I wonder if I should open it up. That's why I keep kind of pausing. I don't know if I know my passwords. My eyes are itching. Okay. PQR, and then this actually ends 3.3. So it tells you to solve, so open P if and only if Q or R. Now, on the homework, it literally will have true, 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 and that's it. This is all it has set up for you. And then it has a little pull down menu for, it's like for different chunks of this problem. It'll have a pull down menu for this biconditional, and then it'll have a pull down menu like for the final answer. But instead of doing it row by row, just solve the whole thing and then just enter in your answers, okay? And what I mean by solve the whole thing is quite literally, it's gonna ask you every row, so why don't you go ahead and figure out what every row is, and then on the homework, you're literally just doing pull down menus real quickly. Second verse, same as the first, setting up a little PQR. And then let's solve it. The first thing I would do is work in my parentheses because I'm in math class. Nothing's being negated. So I would just do this operation, which is the if and only if, which is my doubles. So it's P if and only if Q. So I'm looking here. Those are doubles. These are doubles. These are not. These are not. These are not. Nope. Yep. Yep. Okay. Then, I mean, it's you either could know that you're taking a disjunction of these columns here, but if it makes it easier, I would go ahead and just copy this column here. Hopefully that made sense to somebody. True, false, true, false, true, false, true, false. Now, I'm going to do the disjunction between these two columns that I've worked on. Okay, disjunction is this or this. At least one T gives you a T. So if you see a single, if you see both F's, then you end up getting a false. Okay, is this value or is this value true? Yes. This or this? Yes. Yes. No. Yes. No. Yes. Yes. I have 3 T's, an F, a T, an F, T, T. Now, I would do this on my homework, on my piece of paper. Then when you open up the homework, this is the first row they show you, right? And they're not going to want all 3 of these T's, but you'll be able to tell. It'll ask for the biconditional and it'll ask for the final answer. And then when you submit it, it says, yay, well done. And then it shows you the next row. And you enter the answer. Awesome. And then you do again. And then you do it. But instead of doing it and it confusing you row by row, just do it on your page and then use your answers to like select from those pull down menus. Okay, y'all. So that ends 3.3.